Can you prove this expression? It is too long for me to say, so feel free to pause the video at any stage as you try to figure this out. But let's begin. So, this is a more generalized version of the question, the third we simplified in part 1. Feel free to check that out if you haven't already. Let's start by doing a little bit of algebra. So 2n plus 1 can be written as root n plus 1 squared plus root n squared. Okay, feel free to pause at any stage. So you may be wondering, how do we even come up with this idea, or how did we even start? You got to keep track of what we're working towards. So we're working towards root n plus 1 minus root n. So we want to try to come up with the expression root n plus 1 and root n somewhere. All right, let's keep going. Now, we can see that 2n plus 1 squared minus 1 is our difference of two squares. So we can factorize that and continue to simplify. And we're going to rewrite this as 2 times 2 times n plus 1 times n. Sometimes in proofs that are a little bit more complex, you just need to be a little bit more creative with your algebra, and that comes with practice and seeing this a lot. All right, so now that we've established those two expressions, we can actually go ahead and prove what we're trying to prove. So let's write down our original expression. On the left-hand side, we had this, root 2n plus 1 squared, take root 2n plus 1 squared, take 1. All right, so we're just going to spend a couple of lines to rewrite this and arrive at the right-hand side. So we're going to square root 2n plus 1 squared, which will be 2n plus 1. And then if we square root the expression we had simplified for 2n plus 1 all squared minus 1, we are left with 2 times root n plus 1 times root n. Now, in the next line, let's write 2n plus 1 as root n plus 1 squared plus root n squared, and keep the rest of the expression the same. So take away 2 times root n plus 1 times root n. Does this look familiar? This is our perfect square. So notice how we have a squared plus b squared minus 2ab. A little bit less obvious, but that is how we're going to arrive at the right-hand side. So we can factorize that highlighted expression, giving us root n plus 1 minus root n squared, and then we're simply going to square root it. And since we know that root n plus 1 is larger than root n, because when we square root something, we know it has to be positive, that makes sense. And there we have it. Root n plus 1 minus root n. Thanks for watching. See you in the next one. Hope you enjoyed.